Okay, guys, we're headed toward the end of chapter 9. We're going to simplify our next section. There's several components that are in your textbook. We're going to keep it short, and we're going to look, it's for binomial theorem. We're technically just going to look at binomial expansion using Pascal's triangle, okay? So that's going to be our focus. So that's what this video is for. Binomial expansion using Pascal's triangle, okay? So grab you a sheet of paper and hopefully it's notebook paper. It's got some lines on it. You can start at the top, but get in the middle of the top of the paper. And let's create Pascal's triangle. It's all based on patterns. Ones are always on the outside. And then what you're doing to get the middle, or the numbers on the inside, is you take the numbers kind of in the zigzag pattern there, and add them. So 1 plus 3 gives you 4, 3 plus 3 gives you 6, 3 plus 1 is 4, and then 1 on the outside. So 1 on the outside, add to 5, add to 10, add to 10, add to 5, 1 on the outside. And so you're always 1 on the outside. Then add, add, add. And that's pretty much the basis for, how this thing is built. You can keep going forever. It never stops. So you can take it out as far as you need it. This is as far as we need it for today. There's tons of patterns in it, though what we're going to use it for is for the coefficients for our binomial expansion. Okay, now what I'm talking about is, here, let me take this little thingy out of the way. If I move him over. If you take a binomial, x plus y, and you raise it to the 0 power, anything to the 0 power is 1. So that's my coefficients. Or actually, that's all it is. Well, if I have x plus y and I raise it to the first power, the coefficient of x is 1 and the coefficient of y is 1 because it is just x plus y. Alright, now if I take x plus y and I square it, remember that square the first, twice the product, square the last. Well, if I square the first, that's x squared, 1x squared. Twice the product is 2xy. And square the last is 1y squared. So you're getting all of these coefficients. The lovely part of it is that these are all a perfect match. Now, one of the patterns that I want you to notice, so that you know how to use your triangle, and hopefully you put this on a sheet of paper that you can, as you turn pages and do your work, you can keep your triangle in front of your face, because you're going to need it. Whatever power I'm asking you to raise your binomial to, notice that's the line in the triangle that you need. So if you're wanting to raise it to the 5th power, you need the line that has a 5 in it. If you want the 3rd power, you need the line with a 3. These will be your coefficients. Now notice, if it's the 3rd power, you need 1, 2, 3, 4 coefficients. There's 4 terms. If you're wanting the 5th power, there's 1, 2, 3, 4, 5, 6 terms. If it's the 7th power, there's 1, 2, 3, 4, 5, 6, 7, 8 terms. So notice, it's always your power plus 1 is the number of terms that you have to prep for. Okay? So that's kind of the way it rolls for binomial expansion. Now we're going to start simple. And we're going to grow. I'm not going to do a overkill on the practice. We're just going to do the simple version, and that way you guys can go back and do it on your own. Okay? The simplest version, and this will seem to be a little bit on the overkill, because what I'm going to do is I'm going to give you a structure that works for the larger problems that are more in depth, that need more analysis. And so it is a little overkill for the smaller ones. But if you'll follow this structure on all of your problems, you won't have any issues as you go through. It's all based on patterns. If we have the fourth power, you need to prepare for 5 terms. Now you have, in each term, you have 3 components. You have a coefficient, you're going to have a first term, which comes from the x, and you're going to have a second term, which comes from the y. So, the way I'm going to do this is coefficient, first term, second term. So every term is going to have 3 parts. Okay? And I know that looks really weird. So, coefficient, first term, second term. Now, if you will look at Pascal's triangle for 4, let me flip back. 4 has 1, 4, 6, 4, 1. Okay? 1, 4, 6, 4, 1. There we go. That's where the coefficients go. They were the first placement. That's why you need the triangle. Now you're going to go through and you're going to take care of the first term. How does it behave in the expansion? Well, when you do the expansion of a binomial, the first term starts with this power. And he is going to proceed to step down until he gets to the 0 power. So it's x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0. And make sure you're putting the power outside the parentheses, because if you put it inside, you have served no purpose whatsoever by putting parentheses there. And I realize that right now it doesn't seem to make any sense, but later when we have numbers in front of the x, like when I give you a 2x or a 5x, you're going to really want those parentheses there. All right, now, on the back term, I'm going to do the opposite. The back term is going to start at 0 and build up to your power. Okay, so y starts at 0, 1, 2, 3, 4. So every time you look at this, your powers for each term should add to 4. Every term should add to 4. Now all you have to do is simplify this and you're done. Now one thing that is noteworthy is, remember, anything to the 0 power is 1. So these things that you have 2 elements that are raised to the 0 power, you can basically simplify those, because x to the 0 is 1. Y to the 0 is 1. So if you want to simplify those and just kind of get them out so that they don't bother your mind, you can. Now, in this first term, 1x to the 4th, that's all there is. You don't even have to write the 1. Come to the next one. You have 4x cubed y to the 1st. In all honesty, on this simple problem, you're basically just taking the parentheses out. That's all it amounts to. Remove your parentheses. And remember, on the first power, just don't write the power. And you're done. That's all there is to it. Now, one thing I would like to interject here, just go ahead and take care of it, is what happens if it's a subtraction problem? What do you do? So if this had said x minus y to the 4th, how would that change our problem? Okay, well let's go up in what we have and just kind of modify it to adjust, okay? And I'll tell you what, let me write it in orange. I don't have any orange up there. So this negative right here, that means that wherever I put a y, I would need negative y, right? Okay, so all these little y's become negative y's. Now think about what that's going to do. Negative y, isn't he always going to have a 0 power? And the 0 power is always going to simplify out to 1. So this part is still going to go out. So your first term is always still going to be x to the 4th. Now when you come to the second term, I have negative y to the 1st power. Well, that's an odd power. A negative raised to an odd maintains the negative. So what this negative is going to do is going to change that positive to negative. All right. Now over here, I have a negative y squared. Even power, right? Even power takes the negative. It basically cancels out. So that same thing as what I had before. Okay. Once you get down here, the only difference is now I have an odd power with a negative. So my sign just changes. And on the last one, I have a negative to an even power, so the sign stays the same. So investigate here. What is the difference between these two things? Same, opposite, same, opposite, same. If you have a negative, you will always start positive. And then you start alternating signs until the end. Well, it won't write. It doesn't really matter how long you go. It doesn't matter if you stop on a positive or you stop on a negative. It really makes no difference because the negative is going to be supported by the last term. And the last term, the power increases. So the power is always starting with 0 and then 1, 2. Since that exponent structure is built that way, then your negative is going to behave this way every time. So you can know that if you have a negative, you can solve the problem like normal and then take your pencil, which you should be doing math in pencil, and you can come back and you can erase your positive here and just replace it with a negative. So that's all you have to do if there's a minus sign. Okay, now what do you do if there's a number? Same basic setup. I have a power of 5, so I need to prep for our 6 terms, right? Okay, now, just to make sure I don't mess up, let's come back. I have 1, 5, 10, 10, 5, 1. Scooting back, here we go. 1, 5, 10, 10, 5, 1. And I would have a calculator handy because some of these get large. Now, if you remember, the next one, in the second term, it's always the first one. And you start with the power, and then you march down. That should be a 4. That should be a 3, 2, 1, 0. It's like blast off. Okay, now come and hit the last term. No matter what it is, it's a 2. So take your 2, and you're going to build up. 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. Okay, there we go. Now it's all about can you simplify this. Again, you might want to take a moment. Anything raised to the 0 power simplifies. You don't have to deal with it. So this is simplistic, x to the 5th. Now once you get over here, I mean, if you can do it in your head, by all means do it in your head. This is just 5, but you do have times 2. 2 to the 1 is 2. 5 times 2 is 10, and then you also have x to the 4th. All right, go to the next one. I have 10, but I have it times 2 to the 2nd. Well, 2 to the 2nd is 4. 4 times 10 is 40. And then you have to write down the x to the 3rd. So don't forget your variables in this. All right, come down here. I have 10 times 2 to the 3rd, which is 8. Okay? So that's going to give me 80x squared, and then I have 5 times 2 to the 4th. Now that might be getting a little bit more than you want, but 2 to the 4th is 16 times 5 is again 80 with an x, and then 2 to the 5th is 32. Now we'll pick it up with the more in-depth ones here on the next video. Catch you then.